Welcome. We are working on the international contest Math Kangaroo 2020 for grade 5 and 6. You'll be given 75 minutes to solve 30 multiple choice questions, and after that, you're supposed to fill a bubble sheet of the correct answers here. We'll be going over the questions today. So, we're starting off with the first question. You need a card that has a curvy thing over here. So it's not this. Part C can be an option, part B cannot be an option. Okay, let's look at the top left corner. It needs to have another curvy thing, kind of like a quarter of a circle, because it is, right? Which isn't here on the top left. It's not here either, but it is in option E. So E is our correct answer. Let's move on to question 2. As Amira is walking from A town to B town, she passes the 5 signal posts shown. One of them is incorrect. Which one? So let's figure out. So for this question, I would recommend that we take a look at this example. Let's say you have a circle or an oval and you have a star. Okay, you are here right now at the green thing, and then you moved by 1 kilometer. You'll say that now you're 1 kilometer closer to the star as compared to your previous position. That means you added 1 kilometer to that. But if you look at the oval, you're 1 kilometer farther than you were from the last position from the oval, right? Now, just to kind of solidify this in a mathematical form, because it's farther, we are subtracting from our previous position if you're walking towards the star. Okay, so in this case, if we have A town and a B town, and we have different signposts, if we are walking towards town B, that means we are adding distance to from where we were from town A. But when we look back and we look at how much closer we are to town B, it'll be subtracted, because eventually, let's say it is from this town post, town B is 10 kilometer farther. When you travel 1 kilometer, it's going to be 9 kilometers, right? And let's say town A from this signpost was 3 kilometers. Okay, and when you traveled 1 kilometer, it's going to add, because you have to add 1 kilometer to it, and it'll be 4 kilometer farther. So let's see. By looking at this, you can see that the distance need to increase or decrease, right? So over here, this is +1, right? And 9 to 8 is -1. So the opposite will be happening. This means +2. This means this will be -2, right? Opposite needs to happen. It cannot be +2 +2, because if it is +2 and +2, we're traveling the same distance, and the town are not opposite or like farther from each other. They're in the same direction. This is +3. That means we should have a -3 over here. Then we have +1, but over here we have another +1. So E is the wrong signpost, because this is saying that both the towns are in one direction. However, Amira is walking from town A to B, so they need to be opposite directions. Okay. Let's do the next question. A large square is made up of smaller white and gray squares. What does the large square look like if the colors of the white and the gray squares were interchanged? So let's look at these gray ones over here. Now the gray ones interchanged means there's being switched between or replaced. The gray will become white and the white will become gray. So now if you look at that, these two boxes need to turn from gray to white. So let's look at these two boxes. Yes, they are turned from white. They're not turned to white. One is, one isn't. This is also a wrong option. Here these two are. One is gray, one is white. This cannot be an option. Okay, let's take another example. Let's take another random block. Now this one, this green one needs to be changed from green to white. Top left corner needs to be white. This is white, but this isn't. So D is our final answer. Now, I know luckily the random blocks we picked were all changed and converted and we got the answer, but you can literally take any block, right? You don't have to take these ones. It can be anything, and you just need to see which options do have them interchanged correctly and which ones don't. Okay, Kim has several chains of length 5 and of length 7. By joining chains one after the other, Kim can create different lengths. Which of these lengths is possible to make? So we can take a look at these chains, right? If I were to have 5 plus 5 more chains, I'll be able to make 10 chains. If I add another 5 to it, I'll be able to make 15 chains. If I do a chain with 7 plus 5 beads, I'll be able to do, this can be done, this can be done. I'll be able to do a length of 12. A chain with length of 12, right? If I were to do, 7 plus 5 will give me 13. 7 plus 7 will give me 14. 7 plus 5 will give me 12, and 7 plus 7 will give me 14. But there is no combination that I can make with 5 plus 5 or 5 and 7 together, or 7 plus 7, which will give me 13. So this chain is impossible to make. If you know what multiples are, right, or the skip counting of 5, you will be able to figure out, like, okay, it's 5, 10, 15. Those chain can be made. 7, 14, 21. Those chains can be made. And then say, okay, these are possible. Now I need to figure out if 12 or 13 is a possibility. Now for 12 or 13, if I just look at 7 plus 5, that is the length of 12. So that is not an impossible combination, hence it's 13. So these are the two ways you can do it. Or you can ask yourself, can I use the numbers 7 and 5 to make these numbers, or just 7 or 5? Okay, now we have a question that involves a bat. When Elsley, the bat, leaves her cave, a digital clock shows 2020. After she returns and is hanging upside down, she sees 2020 on the clock again. How long has she been away from the cave? Now, you can see that the key term here is upside down, right? So try flipping the paper, seeing what the time is upside down. It should be 2:02. Now we are going to figure out from 2020 how much time has passed for us to be at 2:02. Now this is, again, remember, it's a digital clock, so it's a 24-hour clock, right? That means 24 hours is when the clock resets. So let's see how many hours will we have to pass to be at 00 or 24 or 24:0. So to go from 20 to 00, we will have to do plus 40 minutes. Right, so it'll be 21 is equal to 0. Why 40 minutes? Because 40 plus 20 gives us 60 minutes, and that's 1 hour, right? Now, to go from 21 to 24, that'll be plus 3 hours, right? And now I need to go to 202 from there. So I'll add 2 hours to be at 2 o'clock plus 2 hours. Okay, moving on to the next questions here. Cindy colors each region of the pattern either red, blue, or yellow. She colors region that touch each other different colors. So let's say if a region is touching both red and blue, the color obviously would be yellow. She colors regions she colors the outer region blue, so it's already given to us that the outer region will be blue, so this one right here will be blue. How many colors, how many regions of the completed pattern can be colored blue? Okay, so let's see. Now, because the outside is blue and it's touching this one and this one, they can be either yellow or red, right? Now I need to go back and see, okay, well, this region right here is touching both yellow and red, right? So the only option we can put here out of the 3 colors is blue, because this region shouldn't touch either yellow or red. Now we have the next region. We know it's touching yellow from here, right? And it's also touching blue from here. That means the only color that can go in here is red. Now, this region right here, this one, is touching both blue and red. That means the only color that can go in it is yellow. And then we have this region, which is touching yellow and red. So blue goes here again. And because the circle in between, the only color that can go here is red, right? So our answer here is 1, 2, and 3. So, B. Maria has had 10 sheets of paper. So I'm going to draw 10 pieces of paper. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there are 10 pieces of paper here. She cuts some of them into 5 parts each. Needs to be 5 part and only some of them. Okay, after that, Maria has 22 pieces in total. How many sheets did she cut? Okay, so we need to figure out how many sheets she cut, because only some of them were cut, right? But eventually the 10 sheets became 22 sheets, right? So what we'll do is cut the first one into 5. That'll give me 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Still not equal to 22. So let's cut another one into 5. So now I have 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, let's cut another one because 22 is more than 18. So 15, 16, 17, 18, 19, 20, 21, 22. Voila. So there were 3 sheets that Maria cut. Now, this is one way of doing it. Another way could be that you just thought that, okay, well, I need to go closer to 22. If I look at the skip counting or count bys of 5, the closest I can get is 15, and I'm left with 7 sheets. And then to have that 15, I'm cutting 3 sheets, right? 3 plus the 7 that I'm missing is equal to 10. That means I need to cut 1, 2, and 3 sheets. And that still gives you the answer. So there are 2 ways you can do this. Okay, a cat and dog question. A dog and a cat walk in the park along the path marked by the thick line. The dog starts from P at the same time the cat starts from Q. The dog walks 3 times as fast as the cat. So when it covers 3 blocks, cat would only walk 1. At what point are they going to meet? So I'm going to give dog the yellow highlighter and the cat will be our blue pointer. So 3 steps, the cat is gonna go 1. 3 steps, 1, 2, 3, the cat is going to go 1 more. 1, 2, 3, the cat is gonna go 1 more. 1, 2, 3, the cat is gonna go 1 more. 1, 2, 3, and the cat is gonna go 1 more. So they'll reach at point E. Awesome. Giorgio has 2 identical pieces of the wire of the shape given. Which of the following shapes cannot be obtained putting together these 2 pieces? So the first thing that I like doing in these type of questions is that I look at the shape and see if like at any point they modified this shape somehow into a different shape. So I have a long line right down. Okay, so I'm just going to trace that. Well, they do have this, right? And the same is happening over here. So the shape is not modified. This, and then this, this, and then this. Okay, this, and then this, which is correct again. This. Oh, this shape right here is not the same as this shape. Because if it were, it would be something like this, right? And we don't have that. So obviously E is something that cannot be put together. Awesome. Okay, Micah's want to bake 24 muffins for his birthday party. To bake 6 muffins, you need 2 eggs. Eggs are sold by the box of 6. How many boxes does Micah's need to buy? So we know that 6 muffins need 2 eggs to bake. That means to bake 24 muffins, well, 6, let's do the count bys of 6, 6, 12, 18, 24. That means we need to multiply 6 with 4, right? That means we had 2 eggs over here. 2 eggs will be multiplied by 4 as well, which will give me 8 eggs. I need 8 eggs, right? But one box only has 6 eggs. I need more than 6, so I'll have to buy another carton of eggs to fulfill my need. So it'll be 2 boxes of eggs are needed. Awesome. This question is like a merry-go-round. The numbers from 1 to 10 have been placed in small circles, 1 in each number. So they have placed 1 number each in a circle. Numbers in any 2 neighboring circles must have the same sum in 2 diametrically opposite circles. So diametrically opposite means this is the diameter of a circle. Opposite to 5 is 10. Opposite to 1 is an empty circle. Opposite to 9 is an empty circle. Okay. Some of the numbers are already placed. What would you place in the circle with a question mark? Now, the condition is that if I have 9 and 5 together, the diametrically opposite to that, opposite to 9 is this, and opposite to 5 is 10. So the sum means adding 9 plus 5 should be equal to adding 10 plus something. 10 plus something is equal to 9 plus 5, which is 14. 10 plus 4 is 14. So that is what will go in here. Now, let's say I'm doing 5 plus something, and it needs to be equal to the opposite ones, which in this case are 10 and 1. 10 and 1 is 11. 5 plus 6 is 11. Now let's do another one. We have 6 and 2, right? Opposite to 6 is 1, opposite to 2 is something else, right? So 6 plus 2 is 8, and 1 plus 7 is 8, so we put 7 over there. Now, kind of reaching close here. I have 7 plus question mark. The opposite to that is 2 and a blank number. So let's see what numbers I'm left with. I have 1, 2. I don't have 3 in my merry-go-round already. 4, 5, 6, 7. I don't have 8 either. So either 3 or 8 needs to go in my box here, like my question mark here. I know 2 plus 8 is 10, and I know 3 plus 7 is 10. That works. My answer is A. If I were to think of 7 plus 8, that gives me 15, but 2 plus 3 doesn't give me 15, right? So that's why 3 cannot go in here. It needs to be in the question mark piece. Okay. Question 12 is about Amy gluing the 6 stickers shown onto the face of a cube. The picture below shows the cube in 2 different positions. Which sticker is on the face opposite to the face of the mouse? So, this is our mouse. We need to figure out who is opposite to that. Now, if you see, this is the arrow for ladybug here, and ladybug is the only one that's common in both of the cube positions, but it changed over here. It's basically like this cube is gonna be sitting like the ladybug will be down over here, I guess, on this paper, which would move the position of our fly to be over here. So our fly will be over here, and then our dog would be above over here. You can say below as well, right? Because the fly is moving, and the ladybug is also standing, so it will be below here. So that's our dog, and if you see, on top of the ladybug is our mouse. So our answer will be the mouse is opposite to the dog. The diagram here shows 5 paths from X to Y with a thick line. Which path is the shortest? Now, they kind of look like a candy shaped, like part A, B, and D look like a candy shaped. And I feel like this is the longest distance here, so I'll just count how many there are present. So 1, 2, 1, 2, 1, 2. That's quarter of a circle, right? Quarter is 1/4. This is 1 and 2. However, this one is only 1 that's present. Let's look at the centerpieces over here. 2, 2, 2, 2, 2, and then we have this kind of thing over here, which kind of tells me that like these 2 pieces for sure cannot be the answer, right? Because they have most of the extra things over here. So let's look at options E, B, and C. So we have, let's look at the straight lines that we have. Oops, 1, 2, 3, 4. 1, 2, 3. So this is still bigger, right? And 4, right? Same distance for these two. And then we have 1, 2, 3, and 4. However, if you take a look, we still don't have the yellow things that are too big, right? You can think of it as like this is still present over here, but it's still not, like the distance of this piece is not equal to the distance of this piece. Hence, the answer is C. Okay, a father kangaroo lives with his 3 children. They decided on all matters by vote, and each member of the family gets as many votes as its age. The father is aged 36 and the children are 13, 6, 4 years old. So the father always wins. How many years will it take for the children to win all the votes? I'm going to start with 7 being our option. The reason why I'm doing this is because after 7, like if it's not 7, I know that it won't be 5 and 6. It would either be these two. So I can look at 14 and see if it's 14 or not and go back based on that. So let's take a look. Okay. Then I add 7 years to each of the members' age. We want the kids to win, right? So let's see how we can do that. 13 plus 7 is 20. 6 plus 7 is 13. 7 plus 4 is 11. And 36 plus 7 is 43. So let's add this. 20 plus 13 plus 11 gives me 44. And that's just enough votes for them to win if all of them agree. Awesome. Okay, the picture shows the friendship of 6 girls: Anne, Beatrice, Chloe, Diana, Elizabeth, and Fiona. Each number represents one of the girls, and each line joining two numbers represent the friendship between the 2 girls. Chloe, Diana, and Fiona have 4 friends each. Beatricia is friends with only Chloe and Diana. So this tells us that one, like whatever denotes Beatricia, will have 2 arrows going wherever, right? And I can see like there are 2 arrows going over here, so this is Patricia for sure. And this can be Chloe or Diana because they are friends with Patricia. Now, Diana, Fiona, and Chloe have 4 friends each. What is depicting Fiona? So let's look at the arrows now. Let's say Diana is this. So she has 1, 2, 3, 4 friends. Let's say Chloe is this. Chloe has 1, 2, 3, 4 friends. And let's see who Fiona is. Well, 1, 2, 3, 4. 4 friends. So Fiona is number 3. Okay, let's do the next question. An elf and a troll meet. The troll always lies and the elf always tells the truth. If they both have just said one sentence, which of the sentence would be true? I'm telling the truth. Well, elf will say that because he does say the truth. And troll, because he lies, he will also he can also say that because it's a lie. So this option can be correct. Let's look at other options. You are telling the truth. So elf won't say that to the troll because elf knows that troll lies, right? But troll can say that. So troll can say that, elf cannot. We both are telling the truth. Elf won't say that, troll can. I always lie. Troll won't say that because it always lies, right? an elf won't say that either, because elf always says the truth. One and only one of us is telling the truth. Elf can say that, but troll won't say that. Okay, because that's true. Elf is always telling the truth, right? Okay, next question. We call a 3-digit number nice if its middle digit is greater than the sum of the first and last digit. Now, if you remember, sum is addition, right? So first we have 3-digit numbers, and they're saying like you always need the middle number to be greater than the sum of the first and the second number. Okay, so figure out what is the largest number of consecutive nice numbers. If you don't know what consecutive is like 1, 2, 3, 4, 5. So we need to figure out like a row of numbers that will always have the middle number bigger. Now, it'll be easier if we have 9 as our middle number, right? Because we can go 190, right? Because the sum of 1 plus 0 is 1, and 9 is bigger than 1. 191, 9 is still bigger than 2. 192, 9 is bigger than 3, because 1 plus 2 is 3. 193, still bigger, right? 9 is bigger than 4. 194, 9 is bigger than 5. 195, 9 is bigger than 6. 59, 156, because 9 is bigger than 7. 197, because 9 is bigger than 8. 198, here 1 plus 8 is 9. 9 is equal to 9, so we'll have to stop here. But we have 1, 2, 3, 4, 5, 6, 7, 8 numbers that can be consecutive and still be nice. Okay. Next question. Mary has exactly 10 white cubes, 9 light gray cubes, and 8 dark cubes, all of the same size. She glues all these cubes together to build a big cube. One of the cubes below is the one that she builds. Which one is it? So let's look at like the bigger, like if you look at a cube, whatever you think has the largest number of cubes, whatever color has the largest cubes, we'll count that, okay? In the first cube, I think like dark gray and light gray kind of have the same, but light gray looks more to me. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 light gray cubes, but she can only have 9, so this is incorrect. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 white cubes, that works. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 light gray cubes, and there might be a possibility that they'll have 8 dark gray cubes, but till now all the conditions are met. Let's look at the next cube. C has more white cubes that are visible. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 white cubes. That's not correct. We only have 10. Seems like there is more dark gray here, so let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9 dark gray cubes, but we only have 8, so can't work, right? C and D are wrong. Looks like more light gray cubes in option E. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 light gray, but we can only have 9, so this option is also wrong. Our only correct option is B. Also, if you don't know, the reason why I'm counting, like for example over here, I counted this as 1 cube is because that is a cube, right? I don't like when we look at the question we did over here, a cube has 6 sides, right? So over here in this picture, these are the 3 sides of the cubes that I can see, but there are hidden sides of the cube that I'm unable to see. Okay. Okay, let's move on. This is an object given to us, and we need to figure out which of these options look like we are looking at this object from the top view. Okay, so what I'm going to do is I'm going to count the light gray sticks. 1, 2, and 3. Okay, and the circle placement. Let's look at the circle placements first. All the circle placements are the same, like we have the same circles, right? But in the circles that are on the right, the ropes that are tying the circle need to be gray. So these are gray. These aren't gray, so option E is incorrect. These are gray. These are not gray. These are not gray either. So I have option either B or C. So I'm going to look at from the side piece over here. I see that there is a black rope. From the side piece over here, there's a gray rope. So this option is incorrect, and my option here has a black rope, so it's option B. The next question. Magnus has to play 15 games of chess in a chess tournament. At some point during the tournament, he won half of the games he played and lost 1/3 of the games. And 2 were a draw. How many games has Magnus still to play in this tournament? So let's say out of the 15, he still has to play 2 games. That means he has finished 13 games, right? Now, is 13 divisible by 2? No. And he cannot win 6.5 games, right? That means this option won't work. Let's look at 15 plus 3. 3 plus what is 15? 12. 12 is divisible by 2. He won 6 games, right? And he lost. 12 divided by 3 is 4. So an L on the 4th game. And then there were 2 draws, right? That means 6 plus 4 plus 2, which gives us 12. That means he still has 3 games to play. So he at least needs to win a game or 2 to win. Okay, now we have a bunch of people standing in a line to get a candy at a fair. Anne, Ben, Catherine, David, Ella, and Fred. The clown that is giving away the candy does it in the following way. He sends the child in front of the line to the end of the line, then gives candy to the child in front of the line, then sends the child in front of the line to the end of the line, then give candy to the child in front of the line, and so on, until all children get candy. Which of the following is true? So let's do the scenario in our head, okay? We have Anne, we have Ben, Catherine, David, Ella, and Fred. I'm just taking their initial name. So because Anne is standing in front of the line, the clown will be like, go back to the line, back of the line. Ben will get a candy, right? So let's look at the Ben's scenario. Ben gets candy after David. Well, David is still standing in the line, so no. Because Ben got a candy, Catherine is going to go to the back. And David is going to receive a candy. And then let's look at the scenario which talks about David. It's only option D, right? Since we already talked about option B. Catherine gets candy after David. That is true. She's still waiting in the line, right? So that's her option. And that's correct. But if you still want to go ahead and do it, David got his candy. Ella is going to go back to the line. And Fred is going to get the candy. Well, Fred did not receive the candy to the last, so that's incorrect. Now, because Fred got his candy, Anne needs to go on the back, and Catherine will receive a candy. So Catherine gets candy after Ella? No, Ella is still standing in line. Anne gets candy before Catherine? No, Anne is still standing in the line. Right? So it's option D. Okay. 3 small squares are drawn inside a large square as shown. What is the length of the line marked with the question mark? Now, you should know that squares have equal side, right? So this are equal length of sides. They all are 28 over here. If I were to find the length of this square, I would just do 28 minus 22, which is 6 centimeters. To calculate the length of this square, the side of this square, it will be 28 minus 15, which is 13 centimeter, right? So it'll be 6 centimeter over here because this is a square, and 13 centimeter over here. Now, because I have this and this length, right, I can just do 28 minus 13 minus 6 to figure out what's the length of the square. So that will be 9 centimeters, right? So this square is 9 centimeter. Now I know that in the box that I have over here with 28, right, this square is 9 centimeter, and I need to figure out how long is this. So all I need to do is 28 minus 9, which is 19, and that's my answer. Steffi took a square piece of paper and folded one vertex to the center of the square. Next, he folded the paper along the symmetry axis of the figure, obtaining a quadrilateral. What is the measure of the quadrilateral's length angle? A few things you need to know is that a square has the angle of 90 degrees. And another thing you need to know is quadrilateral. All the sum of the angles in a quadrilateral need to be 360 degrees. So that means this is 90 degree, this is 90 degree, this is 90 degree, this is 90 degree. When we divide 90 degree into 2 equal parts, we get 45 plus 45. And this is what happened over here. Our 90 degree was divided into 45 degrees, right? And then because there was this thing, it's a straight line, and a straight line passed through it, we are getting a 90 degree angle. So this is 90, this is 90, and this is 45 degrees. We just don't know what this angle will be. And if you know what obtuse angles are greater than 90 degree but smaller than 180 degree, and that is what this green angle looks like. It looks like an obtuse angle. So what I'll do is, I know that all the angles in this quadrilateral should be equal to 360 degree. So I'll do 360 degree is equal to 90 degree plus 45 degree plus 90 degree and plus a question mark. I'm not sure what it is. So I do 360 is equal to 90 plus 90 is 180. 180 plus 45 is 225 plus a question mark. So I'll ask myself, 225 plus what is 360 degrees? And that's 135. So that's my answer. Okay, because 135 plus 225 is 360 degrees. Okay. 3 positive integers have the product 12 and repetition is allowed. Which of the following numbers could not be the sum of the three integers? So let's look at what will lead to a product of 12. Well, 6 times 2 is 12, so we can say 6 times 2, and because it wants us three numbers, we can just multiply it with 1. We can say 4 times 3 times 1 is 12, and we can say 2 times 2 times 3 is 12. We can also say 1 times 12 times 1 is 12. So these are the possible scenarios I have. Now I'm going to add them. 6 plus 2 plus 1 gives me 9. So this cannot be correct because it says could not. 4 plus 3 plus 1. That gives me 8. That's also not correct. 2 plus 2 plus 3 gives me 7. Not correct again. 1 plus 12 plus 1 gives me 14. So my answer is 12. Because that is something that won't be added by the products of 12. Or the factors of 12. Mary put the same amount of liquid in 3 rectangular vessels. Viewed from the front, they seem to have the same size, but the liquids have risen to different levels in the 3 vessels. Which of the following images represent the 3 vessels when viewed from above? So this question is basically telling you that Mary has 3 liquids, and their same amount of liquids, but the vessels that she had were different sizes, and because of that it looks like the liquid has decreased in size, but it's because the length of the vessel is more. So I can say that like the black liquid over here is the smallest, right? From the view that I have, that means it's the largest vessel because all the water, the length of the water decreased. The light gray one is the largest or the tallest over here. That means the vessel will be the smallest. And the first vessel is in between the black and the light gray one. That means the length of the first vessel is medium. The size of the first vessel is medium. So I'll just look at all these things. Well, I see the black is only large in option A, right? And then we have smallest, light gray, and medium. So my answer will be A. Okay, so question 26. There are 8 cards with digits 1, 2, 3, 4, 5, 6, 7, 8. 2 boys and 2 girls sit in some order around a table, starting from one of them and going clockwise. They take one of the cards and put them from left to right. The boys want the final number to be as large as possible, and the girls want it to be as small as possible. Which of the following numbers cannot be the final number? So we don't know how the boys, the girls are sitting. It can be 2 boys together, 2 girls together, boys, girl, 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 boy, 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 girl, girl. It can also be girl, boy, girl, or boy, girl, girl, boy. Okay, so there are different options we have, but we can figure out which arrangement this is based on the numbers that we have. So number 8 is chosen. That's probably because a boy was sitting there. Then a girl, boy, girl, boy, girl, boy, girl. This arrangement does fulfill it. There are 2 girls sitting, then boys, girls again, boys again. Works. Then we have a sitting in which there is a girl, boy, boy, girl, girl again, boy, boy, girl. That works. Then we have a boy, girl, girl, a boy again, and then we have, out of this, the girl chose 4 and not 3. This is a little fishy, right? Because they should have chosen the smaller number first. So I'll circle that, but I want to check option E first. So girl, boy, girl, boy, girl, boy, girl, and boy. That works. So it's option D. Question 27. A rafter takes people across Avaro River, doubling everyone's money in their pocket during this trip. One trip costs 24 coins and you pay at the end of the trip. Alfonso went across the river 3 times. Unfortunately, after paying for the last trip, he had no coins left in his pocket. How many coins did Alfonso have before the first trip? So, how we can solve this question is we can think of it as at the end, he had 0 money, right? The money kept doubling as the trip went. And you have to have $24 per trip. So we have to work backwards from here. What we'll do is, because we have 24 plus 0, we'll half that, which will give me 12. So at the start of the third trip, he had 12 coins. So now we're going to do the same for that. Now we know he had 24 plus 12 divided by 2. 24 plus 12 is 36. 36 divided by 2 is 13. So 36 divided by 2 is 18. So that's for second trip, beginning of the second trip. 18 plus 24 divided by 2. 18 plus 24 is 42. Divided by 2 is 21. So the first trip he had 21 coins and he started off that. So it's a little confusing, but that's how it is. Vadim has a square piece of paper divided into 9 cells and he has folded it as shown, overlapping horizontally and then vertically so that the gray square ends on the top. And the gray square is 1. So if you look at what they have done here, you can figure out that they're reaching a snake pattern. It's kind of like goes here and then goes here, and that is what your folded paper would be. If it's hard for you to visualize, you can get a square piece of paper and do the same and figure out the pattern as well. Vadim wants to write numbers 1 to 9 into the cell. Once the paper is folded, the numbers would be increasing in increasing order with number 1 on the top layer. So that means it'll just be 1, 2, 3, 4, 5, 6, 7, 8, 9. So A will be 6. Can't be this, can't be this, can't be this. B would be 4. And C would be 8. So it's option A. Okay, next question. Don builds a pyramid with balls. The square base consists of 3 by 3 balls. The middle layer has 2 by 2 and there is 1 ball at the top there. They are trying to figure out how much glue will be needed, because at each point, whenever like the ball makes a contact, there's glue needed. So what I did is I made the 3 by 3 base like this to figure out how much contact is being made. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 balls that are contacting in 11 and 12. So there are 12 contact points here. Then for the second base, there is 1, 2, 3, 4 contact points, but because it's being contacted with our with the third base, we need to look at how many contact points are there. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 contact points plus the 4 that were there. Just trying to look closely here. So 1, 2, 3, 4, 5. And then there's contact points being made. It's a little messy, but there is contact points being made with like these over here. So 1, 2, 3, 4, 5, 6, right? So that means in total we have 20 contact points being made. Now there is another ball on the top over here, right? The contact points that are made because of that are 4. We can also look at it over here. 1, 2, 3, and 4 at the back. So 24 and 12. When we add that, that should give us 36. So there are 36 glue points needed. Okay, the next one, final question. The figure in the map shows some islands and how they are connected by bridges. A postman has to visit each island exactly once. He starts on the island marked start and would like to finish on the island marked finish. He just has to reach the black route in the center of the map. In which direction should he move to able to complete his route? Okay, so let's say we start from here. We could do this, right? Let's look at other options. We could also do this. Oh, but it doesn't go through the middle of the map, right? So we could do this, but then we need to complete all our points, right? We need to be on all the islands. So we can look at different options of what is available. Let's do oh, we're so close. Okay, this won't be possible. Let's look at more options. Let's say we go straight, this, reach the map. No, that won't be possible, but what if we do this? No, that won't work either. So when you play around with different options, you'll realize that eventually what will work is this. So we go up, we go over here, this. I'll do that. This kind of like a snake pattern, and we'll reach our finish point. So from the start, if you're trying to go to a direction that would lead us to the finish point of this route, like from the middle point over here, is if it goes east, right? So by going east, they'll finish their route. Okay, thank you guys for listening. I hope this video helped.